Okay, we're doing 3.1.1, and we want to solve this equation right here. X cubed plus 9x minus 6 is 0, and we get this right here, which is y cubed plus py plus q is 0. Notice these look quite similar. This looks similar to this, but it's not in standard form, I guess, with the x cubed plus ax squared plus bx plus c. So first of all, I'd like to say one thing. There's a 1 here because we can divide by whatever that number is and then turn it into this form here. Also, I want you to notice one more thing, which is this a is 0 right now in this case right here. So we actually have to take less steps because we are already in this form. All right, so the next problems will be a little bit different than this one, and the next problems will be a little bit longer. Okay, so first thing I do is use this equation right here. So if you have this right here, then you get this equation here, and then from there you will get 3 values, z1, z2, z3. Okay, let me talk more about that. So we are looking right here, and we're just doing standard math, and then we get here and we get to this part where we break apart into 2 different pieces. Now we could choose either one. We could choose this one or we could choose this one. Either way is just fine and will lead to the same answer. Okay, so I chose 9 because it looks more simple to me. Took the square root, the third root of both sides and got this. Now I went ahead and did my page 20 proposition 2.7 on this, and then I got my 3 values, k when k is 0, when k is 1, and when k is 2. And notice here you get this, and then this I'm going to call omega, and it is right here. It's right there. Now this one is omega squared, right? It's here. And well, yeah, all right, so that looks okay, I guess. All right, so then that leads me to something else. So let's say we have the inverse of omega. So we're looking at the inverse of this. So what I want to do is just do an a plus bi real quick, and then we're looking at the inverse of that. So a plus bi, like this. So what I want to do now is multiply the top and bottom by a minus bi. Okay, so what we're gonna get now is a minus bi all over a squared plus b squared. Now, a squared plus b squared is, just think of the quadratic formula. So a squared plus b squared is c squared. And we're on the unit circle, so that's just gonna be 1, and then we end up with a minus bi. So notice that the inverse of a plus bi, which is this, is a minus bi. So 1 over omega is omega squared. Hopefully you see that connection, but yeah. So you could get to omega squared 2 ways. You could take omega and multiply it by omega and get omega squared, or the inverse of omega is also omega squared. Okay, so I get that's enough of that. But you can also try it yourself. Just check it out. So this right here, I'm gonna highlight it. This is omega squared. All right, because that's the inverse of omega, which is down here, which is omega squared. Okay, so then the third one is just going to be 1, and we are finished getting all these z values. So That's what I did here. That's why I just called them omega, because this is omega. This right here is omega squared, so I just call it omega squared. And then you could call this, if you want, like this could just also be omega cubed if you want, which is just 1. But take these down here, and then this is the formula that you find. By the way, these formulas are all on page 45 and 46. So maybe a little bit, oh, also 47. So you'll notice on page 47, you get this equation here. And that's by combining 2 of the equations. So combine yi equals zi minus p over 3zi. And then there's another equation which is xi equals yi minus a over 3. All right, so if you combine those 2, you get this there. All right, so I went ahead and just combined them straight away. And then that leads us back. So you have the Z1, Z2, Z3, and that's what this whole Zi represents. You got to do all 3 of them, and that'll lead to all 3 of the yi's. Now, I want to talk about this A here. What the heck is this A? So what this A is remember talk about this earlier. This A is 0. So we have something already in this form, so it gives us a bit of a shortcut. We don't have to put it in this form. It's already in that form. Okay, so we are chugging along, and we are now here where we talk about this A value. Right here is what we're looking at. So this A value is 0. So this simplifies to 0 over 3 for all 3 of them. So we basically don't need to worry about them too much. All right. So look in here. I changed this to omega and this to omega. And remember, the inverse of omega is omega squared. So I'm now looking right here. The inverse omega is omega squared. And the rest is just simplification. Yeah, just standard simplification that you can see in pre-calculus. All right, so then right here, the inverse of omega squared is omega. And yeah, again, the rest is pre-calculus, and this is, remember, that's 0. All right, and then right here, this is the most simple one where we have omega cubed or just 1. So we get all 3 of these answers. Here are your answers to answer the question. Here's one of the answers. Here's the other answer. And here's the third answer. And I checked in the back of the book. They are all correct, so I'm guessing all my work is correct. Yeah, that's kind of a lot all at once, but there you go.